Hey y'all, welcome to Miss Clark's chemistry class. By this point in time, we have talked about all that you need to know about naming and writing ionic compounds, molecular compounds. That's including ionic compounds with main metals, transition metals, polyatomic ions, molecular compounds, and acids. 5 different things. If you've not watched any of those prior videos, go and check those out first. This lesson is a cumulative practice of all of those types of compounds. So if you're struggling on any of those, I have all of those links in the description below. Go check those out first, because like I said, this lesson is all about cumulative practice. Everything we've learned so far about naming and writing compounds, all of it, we're going to practice here. Because you know what, to be honest with you, when you think about naming and writing compounds, each individual topic is a breeze. It's so easy. But I'm not going to lie. When you put it all together and you're trying to figure out, is this an ionic compound? Is this a covalent compound? Do I use Roman numerals? Do I use prefixes? Or maybe I don't use any of those. I know, it's a lot when you put it all together. That's why I'm making this video, so we can practice it all together. Go get your notes, go get your periodic table, go get something to write with, and let's get started. So let's look at this first one. NABR. Couple things to think about. The first thing always should be to look at the first element. We've got choices. The first element could be a main metal, it could be a transition metal, or it could be a non-metal, or it could be a hydrogen. This is a main metal. If it's a main metal, you're just going to name it. Now remember, we know it's a main metal because here's sodium. It's in group 1. Main metals are group 1, group 2, and aluminum. When it's a main metal, we just name it. But don't forget to change that ending to IDE. Let's look at this second example. Ca, calcium. We've got to find calcium on the periodic table. Calcium. It's a main metal. Again, we're just going to name it. Oh, but look. Polyatomic ion. C2H3O2. Here it is right here. It's acetate. So this is just going to be calcium acetate. Let's look at that third example. P. That's phosphorus. Let's look at the periodic table and find it. Oh, here's phosphorus. It's a non-metal. Since this compound is starting with a non-metal, that's a molecular compound. That's when we need all of those prefixes. We have a 2 and a 5. So we've got di and penta. Diphosphorus, pentoxide. That's a molecular compound. Let's look at our next example. Again, you've got to look at that first element, Ti. Ti is a transition metal. It's not in group 1, it's not in group 2, it's not aluminum. So we've got to figure out what its Roman numeral is. First I'm going to write titanium, leave a space for its Roman numeral, SO4. SO4, that's a polyatomic ion. SO4, that is sulfate, and it has a -2 charge. So if I put a -2 on sulfate and there's 2 of them, remember the shortcut. Multiply, then divide. There is no number over here, so that's a 1. 2 times 2 is 4, divided by 1, that's still 4. Roman numeral 4, that is IV. And then SO4 again was sulfate. Titanium, Roman numeral 4, sulfate. Let's look at this next example. FePO4. Iron. Fe is iron. Again, transition metal, must have a Roman numeral. PO4. PO4, that's phosphate. Phosphate has a -3 charge. So if we write iron, I left a space for our Roman numeral, phosphate. Phosphate has a -3 charge. Now we would multiply and divide. But let's notice something. This phosphate does not have parentheses. When a polyatomic ion does not have parentheses, that means there's only one of them. Don't multiply your 3 times your 4 to get 12, because you only multiply it by the number of polyatomic ions that we have. And like I said, no parentheses means it's only a 1. So 3 times 1 divided by 1. 3 times 1 is 3, divided by 1, still 3. This is iron 3 phosphate. Let's look at the next example. K3N. K, that's potassium. Potassium is a main metal group. So we're just going to name it. K is potassium. Nitrogen, which we're going to change the ending to "ide." That's just potassium nitride. Number 7, SO2. S, that's sulfur. Sulfur is a non-metal. Non-metal means molecular compound. We just use prefixes. There's only one sulfur, so we're going to use, oh, nope, we can't use mono. Remember, names do not begin with mono. So we're just going to write sulfur. And then 2 oxygen dioxide. Our next example, CuOH. Cu, that's copper. Copper is a transition metal. We need a Roman numeral. Okay, so I've got copper, got us a place for our Roman numeral. OH. OH is a polyatomic ion. OH, it's a -1 hydroxide. So copper, place for our Roman numeral, hydroxide. Hydroxide is a -1. Again, no parentheses. That means there's just one of them. And we've only got 1 copper. That's 1 times 1 divided by 1. 1 times 1 is 1, divided by 1, still 1. Roman numeral 1. Copper, Roman numeral 1, hydroxide. Yes, you've got to put the Roman numeral. Zinc, Zn. Zinc is one of those special transition metals that always has a +2 oxidation number, so it does not need a Roman numeral. So we're just going to name this zinc NO2, polyatomic ion. NO2 is nitrite. Right here, NO2 with the -1 charge. This is just going to be zinc nitrite. And then our last naming example, V2S3. Let's look at that first element, transition metal. We need a Roman numeral. V is vanadium. We'll leave a space for my Roman numeral. S is sulfur. We're going to change that ending to sulfide. Now we got to figure out that Roman numeral. Sulfur is a -2. So we've got 2 times 3, 6, divided by 2, 3. 2 times 3 is 6, divided by 2 is 3, Roman numeral 3. Okay, so this is some examples of how to name when it's all mixed together. It's all about identifying that first element and then figuring out what to do from there. Now let's write formulas. Now we really only have 2 options when we write formulas. We're either going to use the prefix and write what it tells us to write, or we're going to get charges and crisscross. So let's give that a try. Silicon dioxide. Oh, there's a prefix. We don't have to look at the periodic table. We know this is a molecular compound. We're going to use that prefix. Silicone is Si. There's only one of them. We know there's only one because there was no prefix. And then we've got dioxide, O2. Nickel 3 sulfide. We know that nickel is a transition metal because it tells us Roman numeral 3. So we've got nickel plus 3, sulfide. Sulfur is in group 16, so it's a -2. So we've got to crisscross them down, 3, 2. So our final answer is Ni2S3, and then we would need to reduce it down, but it's already reduced down. So that's our final answer. Let's look at number 13, manganese 2 phosphate. Manganese is a transition metal because we see that Roman numeral, but the Roman numeral tells us the charge, manganese, Mn with a +2. Now phosphate, that ending ATE, that tells us polyatomic ion. Phosphate, PO4 -3. +2 -3, that doesn't cancel each other out, so we need to crisscross down. So our final answer is going to be Mn3. Now, since we're going to have more than one phosphate, we need to put that in parentheses. PO4 2. And that's our final answer. Mn3, PO4 2. Number 14, we've got silver acetate. Now, silver is a transition metal, but again, just like zinc, it always has the same oxidation number. Silver is always a +1. So we have Ag +1, Acetate, there's that ending ATE again. That's a polyatomic ion. Acetate, C2H3O2. It's a -1 charge. C2H3O2 -1 plus 1 minus 1, they cancel out. So that's just going to be Ag C2H3O2. Number 15, diboron tetrabromide. Prefixes, they tell us what to do. Diboron, B2, tetrabromide, that's bromine, Br, tetra, that's 4. We're going to skip 16 because we have not talked about that yet. That's going to be a later video. 17, potassium carbonate. There's no prefixes, so we've got to get charges in crisscross. Potassium, that's K. It's in group 1, so it's a +1. Carbonate, that ending 8, that tells us a polyatomic ion. Carbonate, CO3 -2. +1 -2, that does not cancel out, so we need to crisscross them down and reduce down. K2, CO3. Since there's only going to be one CO3, we can just leave it just like that. That was a lot, right? But I'm hoping you're feeling much better. And if you're not feeling better, I hope you know which topic you feel the weakest at. Because I have every single one of my tutorials about naming and writing chemical formulas. They're listed down below in the description. So if you felt weak at any one of the examples that I gave, go and find that exact tutorial and practice a little bit more. It's all about practice. I know you can get it. Like I said, I've been teaching this for many, many years. And the one thing that I know for sure, if you want to understand and you're willing to keep trying and trying and trying and practicing, you'll get it. It's all about your perseverance. I hope you're willing to continue to try until you understand. Until next time, bye y'all.